about source stuff. We do load testing, real user measurement, and functional testing at mobile phones. So what I'm going to talk to you about is the real user measurement component, specifically how we load our JavaScript onto customer websites, and kind of research we did to make that happen as fast as possible. So, part one. We're going to talk about in two parts if we have time. But part one, we use JavaScript. We use JavaScript like this. Alright, few people. What's the problem with this? There's reasons you might want to use it, there's reasons you might not. The problem is that it works well with browser look-ahead. So if you have a script node in your page, most modern browsers will actually be able to pass the HTML before it actually starts executing it, and start downloading the scripts before they actually need it. So it works well with browser look-ahead, but it blocks everything. So any inline JavaScript is actually going to stop rendering the page at that point until the JavaScript is completed and executed. And the reason for that is because some JavaScript has things like document.write, which can actually change the HTML, which means the browser can't actually proceed with the HTML until it's done everything there. So to fix that, you could use something like the async attribute or the before attribute, which tells the browser, hey, I don't have any document.writes in here. That's basically what it tells the browser. And the browser can go ahead and defer loading to the end of the page or actually load it in parallel with the page. Problem is that doesn't work across all browsers. And it doesn't work consistently across all the browsers where it does work. So we came up with a different way several years ago. We came up with this. Who does this? To learn JavaScript. A few people. So document.createElement script, which is JavaScript that creates a script node, and when we attach that to the DOM will actually, the browser will actually start loading up the JavaScript that's referenced by this particular element. This is pretty good. It'll actually load JavaScript asynchronously in the background, and whenever the JavaScript is done, you'll actually get an onload event on that particular node and can start doing things. The problem is, because it loads in parallel with the page, nothing on the page can actually reference that JavaScript until it knows for a fact that the script has loaded. Which means you will have to wait for that script to load and then execute your JavaScript. Or you need to figure out some kind of tricks, because there's no telling when it's going to load. And secondly, it's still going to block the onload event. So the onload event is typically tied to the browser spinner, and research has shown that a lot of users will actually wait until the spinner stops spinning before they start interacting with the page. And that we've tended to reinforce that behavior because a lot of pages tend not to work until the scripts have loaded, which is actually waiting until the onload is done. So, what many developers came up with several years ago is the method queue pattern. Who uses Google Analytics? Right. Do you know this little array that you define called _GAQ? Right. That is essentially the method queue pattern. This is some code that I've written up. Define a variable, an array, right up at the top, then add your element, your script element, and you keep pushing methods onto that array. So empty.push, and whenever that script is available, it's then going to start looking into the page to find this variable. So that variable name has to be predefined. It's sort of an agreement between the script and the hosting page, saying this is the variable I'm going to use where my methods are going to be pushed onto. So that's my method queue. And then your script needs to change a bit to say, all right, I'm going to start looking for this method. Once I load up, I'll look for this method queue, and then I'll start running through all the elements in that method queue and executing those methods along with their parameters. So the cool thing about JavaScript arrays is that you can push mixed content types on them. So one of the elements can be an object, another can be a function, another can be a string, and so on. So, which means these methods which you push on here, the method names themselves can be strings, but the parameters can be of any data type. So it could be integers, it could be callback functions, anything you want. And so the script needs to be modified now. The script that's just written to be run synchronously, loaded synchronously, will not work or may not work correctly when loaded asynchronously, because it's not expecting this method queue. So you need to modify a script as a third-party script author. to expect the method queue and then start reading methods off that and execute. Everything okay so far? Because it's going to get worse. So that takes care of number 3. Number 3 was no telling when it will load up. So we no longer need to know when that script is going to load up because we have a way of calling methods in the script before the script has loaded, and it's just going to run at the right time, depending on your definition of right. So, problem is it still blocks the onload event. Right? Any script added to a page before the onload event is going to block the onload event. So, up until maybe last year, the only way to load up a script without blocking onload was just load it after onload applied. And even then, in Opera, it would sometimes still block onload. Opera has this amazing ability to block an event that's already happened. So, luckily, those 3 users make others bitter. So iframes to the rescue. Now, who uses iframes? A few places people use iframes. In the past, we've always told people iframes are bad for performance. If you've got iframes on a page, it's going to make your performance worse because that page is going to now wait for the entire sub-page within the iframe to load, right? And you're going to block a lot of things. But here I'm telling you to use iframes to improve performance. So, how do we do that? Iframes block until the subpage is loaded. So, we use an interesting trick. We use an iframe which has no subpage. More JavaScript like I promised. The trick in here is that little line that says iframe.source is equal to JavaScript false. Okay. So a lot of it is the same as what we did for creating the script node. We create a new iframe, we add it to the DOM, but right in the middle there we say iframe.source is equal to JavaScript false. And that's the key to this whole method of loading up something without blocking the onload. We do a few other things like set the role presentation that's to stop screen readers from actually seeing that iframe, because it is in fact just a hack that we're putting in. It's not something that has any visual impact. But essentially, JavaScript false. What do you think happens when you set source of something to JavaScript false? So if you set a link, so href is equal to JavaScript false, and you click on that link, nothing happens. Same thing happens when you do it for an iframe. You set source equals JavaScript false, nothing happens. It's a great way of loading in, putting an iframe on your page without actually causing it to load anything. Depending on the browser, sometimes if you don't put a source, it might actually load the current page in that iframe. So we don't want to do that. Some people have put like a pound sign that actually will load the current page in all browsers, because the pound sign just says hash for the current page. Some people use about blank, which works everywhere except Internet Explorer 6. So we use JavaScript for
empty string will also load the current page.
Yeah, not in all browsers. So newer browsers, Chrome 24 and I guess all versions of Chrome actually will not. I don't know about which versions of Kali will not load. Yeah, there's also something like if you actually don't have a source attribute, it's different from having a source attribute that's empty. So essentially, have a source attribute and explicitly set it to something that you know what's going to happen. So JavaScript false is the key to solving most cross-domain issues. The problem with most iframes, at least when loading JavaScript across them, is if you load up a new document in that iframe, which is on a different domain, the iframe and the parent page cannot communicate with each other because of cross-domain issues. So the browser throws a security exception. Setting it to JavaScript false has this interesting thing, and you should all try this at home, or if you have your computers here, try it now. Create a page, create an iframe, and then go into the iframe and look at location.href. So create a page with an iframe with JavaScript false as the source, and then look at location.href inside the iframe. It's actually the same as the parent page, even though you've explicitly set it to JavaScript false. And the domain is also the same, which means this frame and the parent page can now communicate with each other. You can call methods across the frame boundary without a problem. Like I said, about blank is a problem on IE6 because according to IE6, about blank is insecure content. So if your page is on SSL and you have an iframe with about blank, you're now trying to cross an SSL boundary, which is not allowed. So that all works except if the developer actually sets document.domain on their page, which is something we realized after we pushed out to production. And we got some, I mean, who sets document.domain? But some people do. So we found out that they set document.domain and it was throwing an exception because if you set document.domain, even if you set document.domain is equal to document.domain, is different from not setting document.domain. They're now two different domains. So the iframe which has not set document.domain or the parent page which has set document.domain equals the same domain that the iframe is actually on, now considered different domains. So we have a trick. Yeah, I couldn't have said it better myself. So what we do is use try and catch JavaScript. We try and get a handle to the iframe's window object from the parent window. And if that throws an exception, it's most likely because they've set document.domain. There are probably a few other reasons why, but this is the most likely case. So if they've done that, then what we do is we catch document.domain from the parent page and then go and write it into the iframe. And by doing iframe.source, instead of doing JavaScript false, we now do JavaScript where d is equal to document.open, which opens the document inside the iframe when the iframe is being created, and then writes just one line, document.domain is equal to this new domain which we got from the parent. Right? It's all very hairy, and you don't want to have to deal with it, which is why I've taken it down so you can just copy and paste that code. But essentially, it puts the same domain into the iframe. And so now, all that lets you do is access the window object of the iframe. You still haven't actually loaded any JavaScript into that iframe. Let me go back a bit. So in here, we've just loaded the iframe. We're still not talking about putting JavaScript into the iframe. Over here, we've been able to load the iframe with document.domain set, but we still haven't loaded JavaScript into the iframe. So that's where we come to the next part. So actually telling the iframe to now load up our JavaScript so that it can load within that iframe. And here's where we do the trick that prevents us from blocking the onload event. What we do is we create a function, the same old function we had to load our JavaScript asynchronously, but now we fire that function on the iframe's onload event. So inside the iframe we have body onload is equal to the function to load up JavaScript. And here's what happens, is when you have a page with an iframe that has no source or an empty source, source set to JavaScript false, its onload event fires immediately. Once its onload event fires, it's taken out of the blocking queue for the parent page. So now it's no longer blocking the parent page. And once that happens, you can now load other content in that iframe without blocking onload of the parent page. So what we're doing is essentially waiting for the onload event of the iframe, which fires immediately, right? And then executing our code in there, which will load up the JavaScript. So this is all going to happen in parallel with the parent page, except it's first going to take itself out of the blocking queue, right? And that's the trick that allows us to load JavaScript without blocking. Why is this good? Well, me as a third party, or let's say using Google Analytics or using Facebook widget, and do you want your site to go down and my site to go up? Most people say no. Not everybody answers yes. So I'm going with no. So if my site goes down, and let's say you were loading my JavaScript using one of the two methods, if you're using the first method, your page is just not going to show up. Right? You're going to have a blank page until that request times out, which could be up to 60 seconds. On max, it could be 120 seconds. And your user's going to wait 2 minutes for your page to show up. If you're loading asynchronously, it's still going to be spinning for 2 minutes. Right? Using this method means if my server is down, I've had an earthquake or I'm under a DDoS attack or something, you are not going to be affected by that. Okay? So it's good for third-party script authors to write their code this way so that customers of that JavaScript are not affected. Right? Notice that we said document the domain again. Who noticed that? Jonathan, have you seen the chart? So, I said document the domain again, not here. And the reason for that is because, remember in the first case I said iframe source is equal to this. So that has some JavaScript in there, but now I've got the content window and I'm writing into that window, which means I've blown away everything which was there before. So all of this is now gone, which means I have to set up all of that context again. So remember, the first part was just to get the handle to the window. The second part is now to write into that window, which means I have to set up all of that scaffolding again. So I have to set document the domain again. And it's important to remember we only set document the domain if the parent page is set. Because if you do it anyway, now you're going to be in a different domain from that parent page. So think of it, your domain is not just scheme plus host, it's also plus has documented domain being set or not. So 3 things. Well, I should mention that it's actually different than Internet Explorer and other browsers. Surprise. Other browsers, if you set documented domain to itself, will treat it as the same domain, so not being changed. Internet Explorer will set that flag if it's even if you're setting it to itself. So some weirdness. But it doesn't work in all cases. Because there may be cases where this page developer loads our JavaScript and then sets documented domain. So that change of documented domain was not visible when we actually ran our JavaScript loader. I have no ideas at this point. We have come across one person who does this. So if you have ideas, let me know. A few things to note. So inside this function, that's this function that I've created. Whenever we say document in here, it actually refers to the parent page's document, and the same with window. But if I say this, it refers to the iframe object itself. So I had a hard time with that because I assumed it's going to be running within the context of the child page. It was, except it was defined in the parent page. So because of JavaScript's closures, document was from the parent page and not from the child page. So it's important to alias document and window for parent for the child page if you need that. This is confusing. That's why you have code to copy and paste. Okay, global, also all global variables inside that function. Even though the function is running inside the iframe, global functions defined in there are globals of the parent and not of the child. Any globals defined within your script that are loaded in the iframe, however, are global to the iframe and not to the parent. So, for Boomerang, which is where we use this, we do a bit of aliasing inside our JavaScript. We detect whether we're in the iframe or not, and if we are, we'll just create a proxy object in the parent that mirrors our global object in the iframe, so that you can just not think about it, access our global regardless of which frame you're in. So, because those globals are different, that changes the method queue pattern, right? So previously our method queue pattern just looked for a global object in the parent. Now we have no idea which window or which frame we're going to be in. And keep in mind that customers might load you in any one of these 3 methods. So you need to be prepared for all that. So what we do is we set global to the window object. And then we check if window.parent is not the same as the current. Then we're probably running within an iframe, except we don't know whether we've loaded ourselves in an iframe or we're just running in a page that happens to be in an iframe. So we also set an ID for our script node which we added. Sorry, not for our iframe that we added, we set an ID. So we go back all the way right here. Set JS ID, and that's just a marker to tell me that we're running inside an iframe that we ourselves created. So I can check that and say, all right, we're running within an iframe, we know that, and this particular node that I created exists, therefore we're running in an iframe that we created. And so we're now going to proxy and say, instead of being window object, it's going to be window.parent, which is where the page is going to be. And then we're going to access global.mq instead of just accessing _mq. Everything else should work perfectly. Any questions at this point? It tends to get easier after this. So, remember, global refers to the parent window. So now if a script like Google Analytics or Boomerang needs to attach to several event handlers. Right? We attach the onload event, we attach to onunload, attach to onClick. But we want to do all of this in the parent window. So now we're going to attach to global.onload and global.onunload and so forth. But if we want to do any kind of hacks and testing things within the browser, we can afford to do that within the iframe and not actually affect the parent frame. So if we want to load other scripts, we want to load images to do testing and stuff, we can do that within the iframe without affecting the global context of the page itself. So it gives us, even though we added this method to sort of deal with onload issues, it's given us a lot of other benefits in terms of not interfering with the parent page when we're doing a lot of measurements related to performance. So, summary, that only part. Create an iframe with source set to JavaScript : false. Set document.domain only if required. I said it twice. Santa Claus checks with this. Write dynamic script node into the iframe's onload event and aligns the parent window object into the iframe, so that now your script, which is loaded in an iframe, loads asynchronously, doesn't lock onload, but still pretends like it's in the parent frame and can access all variables, and you can call all its methods. That's all. This is normally the place I put little kittens and stuff. It's documented in much more detail on this blog post that I put up, and the slides are online, so you don't need to write it down. There's also a proposal with the W3C to reduce all of this to one line saying async is equal to non-blocking. We expect it will be in browsers by 2027. So, part 2.
In the meantime, what's your confidence level that this will still work, say, 6 months from now?
It's worked for 12 months or so far, so my confidence is going up. So a lot of the techniques developed here have actually been available in browsers since, in fact, it works in 96. So it's been available in browsers since the 90s. Which means this hasn't actually changed what browsers are doing in over 10 years. So we are not the only people doing this. Facebook is doing it now for their widget. So if you get the latest code to load the Facebook widget on your page, we're using this asynchronous non-blocking method. Meebo used to do it for a long time until they shut down. Actually, are they shut down or are they still running?
I think they got bought.
Yeah.
They got bought by Google, but I don't know if Google's running them or not.
I think they're just their IM client or whatever is shut down. I don't think the whole thing.
So it was the Meepo bot that they were loading using that. Olark is another customer, another company that's doing this to load they have a customer service chat widget that's also using this non-blocking method. And this technique was kind of developed in collaboration with all these people. So the guys at Meepo, guys at Olark, Stoyan from Facebook. I did some work and a whole bunch of unaffiliated people just working and sort of adding to the solution, and that's why it's gotten so long, but it actually works in a lot of cases. So we've come to part 2, and I'm going to slow it down by showing pictures. So we have Boomerang set to cache for 7 days. 7 days allows us to push out new versions fairly frequently. It also allows us to see how long caches actually, objects stick around in people's caches. So, how soon does it take for a new version of Boomerang to get to people? And this is a chart I made from data last week. We pushed out 2 different versions of Boomerang, one on July 12th, 3 versions, one on July 12th, one on September 26th, and one on October 8th. And so the blue out here is the number of people that were sending us beacons using the version we pushed out on July 12th. The red is from September 26th and green from October 8th. And when we pushed it out, which the first time when we pushed out on September 26th version would have been pushed out on 28th or something. So a day's worth of testing before we pushed it out to everyone. It took about, in 24 hours, about 73% of all requests were coming in with a new version of JavaScript. So that means in 24 hours, 73% of all users had refreshed their caches. The same thing on October 8th, when we pushed it out, that was midweek. We found that after 24 hours, only 42% of people were using the new version of cache. So, there's a question to everyone. Why do you think that is so? Why do you think that on a weekend, cache take-up was so much faster than on a weekday? And you know that I'm caching for 7 days. Yeah.
People visit more different pages, more likely over the weekend.
Right. So that's one likelihood. People visit different sites on the weekend than on a weekday, and therefore there's probably 7 days between the sites that you visit on weekends. So your cache is probably stale by then. On weekdays, you might be visiting the same sites every day, so your cache is more likely to be just 24 hours old rather than 7 days old. That's the most likely possibility. To dig deeper into this, we went down and looked at it hour by hour. So if you look at it on weekends, within 2 hours, in fact, most people had got the new version. So it wasn't 24 hours, it was 2 hours to get to the to 73%, and after that it sort of tapered out at 78 to 80%. That is the hourly ratio, right? So average across the whole day was still 73%. But it sort of shows that people were browsing more or less at night. So more likely to be browsing at night. Whereas on the weekday, after 12 hours, only 0.2% of people had the new version in cache. And it took about 19 hours to steady out at 77%. So it was still pretty fast from the time it started, about 6 hours or so. We got it fairly, in fact, 2 hours we got from 0.2 to 65%. So the amount of time it takes to fill up a cache is about the same from when people actually start using it. But it sort of points to different browsing habits as well on weekdays versus weekends. So this is the problem if we have emergency fixes. So you see we've got to 73%, but even after several days, there's still a small percentage of that blue line there. And in fact, I'm going to show you something else here. I'll show you that first. So this is actually all versions that were pushed out since July 4th, 2012. And I got this data today. And we got 2 visits from somebody using the version we pushed out more than a year ago, with 7 days as their cache refresh time. And so this is running from maybe 5 to about 60 requests. So the more recent ones, and I've only put up versions until April. So even versions as old as April, which is definitely more than 7 days ago, still sending us a fair number of beacons. Not a lot, not like in the thousands, not in hundreds of thousands, But still, it shows that there are some browsers or some users with some characteristics that are not ever refreshing the caches.
Do you think it's the developers copying your script down and posting it themselves?
That's possible. So I did some checking on like the user agent and IP address. The most likely culprit seems to be bootcamp proxy. Proxy SG, I think it's the same proxy with different names. But again, there were exceptions. So there were the majority of them had that header that said they were running through the proxy, but not all. So my guess is there are some proxies that will just cache objects forever, regardless of cache headers. So let's go back here. So we have a problem if we have to push out emergency fixes. So what do we do to get around that? Well, what we use is how do you bust cache when you have a far future expires? That's the main question. So if I've already told the browser to cache this object for 7 days, how do I now tell it, hey, don't cache it anymore, read the new one? Because it's never actually going to come to my server to find out that it needs to read the new version. I should also mention that we cannot actually change the file name. So if you're developing your own site, you have your own JavaScript, you can just use version URLs and change the version every time you change the file. We can't do that as a third-party script author because then we have to go out and tell thousands of, if you're Google Analytics, hundreds of thousands of websites to then change their snippet. That's not going to happen. So we need to figure out some way to do that. So more code. Who's ready for more JavaScript? Alright. That's it. So the trick is passing true to location and reload. Turns out if you call location.reload true, we'll go ahead and reload everything ignoring what's in its cache. Everything on that page. So what we do is a little more detail, but before I get you, create an HTML page that just includes the resources we need. So it includes our JavaScript with a static script node, so completely blocking synchronous script node. Anything else, so if you're doing this for your own sites, your CSS, your images, anything that you want to refresh from cache, just put them as a whole list in that page. Right? Load that page into an iframe after the onload event has expired. So you load it whenever the user has finished downloading all their content. And then just say location.reload true. And the browser will go ahead and reload all of those resources, ignoring what's in its cache. So it will force it to go back to the server and refresh its cache.
That the page you load has to be, I guess, version. So
it does not. So that's the cool thing, and that's what's this next slide about. Is what I do in my case is we have this HTML page, and we just put question mark version number onto that. So yeah, it is sort of version, but what we use that version for is to compare with the version of the JavaScript that we think should be in the cache. So we pull out required version from location.search, which is everything from the question mark onwards in your URL. We compare that with scripted version. Right? And if it's less, so if script version is less than the required version, we just reload. If it's not, we don't reload. And the reason we have to do this is because, so it could be just as simple as reload and then do nothing. Set a marker saying we have reloaded and do nothing else. The problem was Firefox 3.5.11. So the original marker we were using was to change the hash in, so whenever we reloaded, it said location.hash is equal to reloaded. So we just check for that and say, all right, this guy has refreshed his cache. Firefox 3.5.11 ignores location.hash. You can set it as many times as you want, and when you try to read it back, it's empty. And then Internet Explorer.
On the iframe?
Yeah. And then Internet Explorer 8, if you mess with the location hash, will add it to the history. So when the user hits the back button, it'll actually just go back to the page that had the old version, instead of actually going back to the main page in the browser. So we stopped using location and hash, we started using this version thing, which actually works much better because if they already have the latest version, we just won't refresh it. And if they don't have the latest version, they'll go ahead and refresh it. So we load this into an iframe using something like this. reloaded an HTML question mark version number, and that's it. We can cache reloaded HTML forever. Now, obviously, because it's got a query string parameter, it's not going to be cached, but you can push it to your CDN, cache it on your CDN forever. You never actually have to serve it from origin. So it's still going to be served from pretty close to the user. It's going to be loaded after onload, which means it won't block anything from the user. And some other quirks we found with caching. For some proxies, ignore all cache headers. They'll never clear cache. I showed you the image, which is actually going to come up next. Some user agents have broken clocks. So the clocks are either set into the past or into the future. If they're set in the past, that means you have an expiry date on your cache, on your objects. Those objects are always going to be expired. Those objects are never going to be expired. Because I'm assuming your expires date is actually in the future. Their clocks are in the past, so it's always going to be in the future for them. If their clocks are in the future, your objects are always going to be expired, and so they're always going to load from origin. Nothing much you can do about that. Some versions of Chrome have a cache corruption bug. So if Chrome is shut down, or rather you shut down your computer while Chrome is running, they haven't had a chance to close the cache index. When they load up, they'll find the cache is corrupted and just throw away everything. So browsers are going to go back to the origin. And interestingly, cache control headers are honored by all pre-browsing. So if you have a link rel is equal to prefetch or pre-render or something like that, it's going to honor your cache control headers. So it'll pull things in, put it in cache. Importantly, if you have something that's not cacheable or has a cache timeout set to right now, then don't pre-browse it. So don't use pre-render because it's not going to do anything. You're still going to make a second request with an if modified since header to the server. Does that make sense to everyone?
So how do you put the version training right, or the version?
So because you're loading it through your JavaScript, so your JavaScript itself, I get this in. So the way we do it is our JavaScript actually calls back to our server. It needs to send a beacon at any
So it's multiple requests.
So you could do it on the beacon itself. Most people use an image beacon, you could use a script beacon. But you can do any kind of beacon that needs sending data request. So we actually have a configuration that's loaded up from our server once our script is loaded up. And that's what tells it, this is the version that you need to, and then it goes ahead and refreshes.
And then that beacon can never be cached.
Beacons are never cached anyway, because they always send back to them.
So even if everything is in cache, there's still at least one request that will always happen.
Yeah, those always happen after download. And so the beacon needs to be sent out anyway, because you need to do analytics and stuff on that. It's just sort of piggybacking on what's being sent anyway. So back to this image. A lot of those were just like single requests. So I'm not so worried about them. Jan 10, Feb 6. It means a single request that was actually the beacon that came in that then told it to go ahead and refresh its cache. So that's why we can't see any more requests from those versions. But there are several other versions that do have. There's a blog post about this as well. On the LogNoll blog. Again, these slides are online, so you can go ahead and get them. So, thank you. Any questions? And I'm going to give away some t-shirts.
So, if you were a customer of many third-party pixels, how can you use any of these techniques to simplify?
So the bad news is that third-party script actually has to be modified in order to work with these techniques. So there are a few things you might want to do as well as actually go tell your third-party script or vendor, these techniques exist, go ahead and do that. Shame on you for not doing it. If they don't do this, there are some scripts also don't support SSL and stuff. Just stop using them. There's a lot of more bad than good you can get out of it. Or does it actually need to interact with your page? Sometimes it doesn't need to interact with your page. Load it in the library. So for a long time, when the Facebook widget, before they actually added this technique, you could just load them in an iframe, which means you could load that iframe after all of it, or you could just load their script after all of it. So sometimes these scripts don't need to be on your page before all of it. You can just refer them to after the all of it. So there's various ways around. Things like Google Analytics, Boomerang, other analytics tools might need to be on the page before all of it. So the only way you can do that is actually just by Google. And at least with us, you have a contract, so you can't. What do you want, a book or a t-shirt?
T-shirt, so I got that on lawsuit.
You want a big size or one size?
No, it's a really, come on.
I think big size one.
I'll take the men's size. Thank you.
All right, any other questions? 3 books and a t-shirt. Yeah, please.
I was going to say, this technique is when you must, your JavaScript must be in the page before onload.
Yeah.
So you don't need to do this unless you really need to use it, because you're measuring everything coming in, right?
Yes, that's right.
Yeah.
So yeah, you do need to be, this is mainly for scripts that need to be on the page before the onload event fires. In fact, we want to be on the page as early as possible. So we tell people, put us in the head right before your title, because then you can start downloading in parallel. There are a lot of scripts that don't need to be on the page before onload, but they won't tell you that when you're going to the script to actually put on your page. Right? So you need to, as a developer, you need to know which scripts need to be on the page before and which scripts don't. So another thing is like tag managers. They need to be on the page early enough. A/B testing software, they need to be on the page early enough because they're going to delay what actually shows up on the page. So you want to talk to those kind of vendors. The others, you want to know that these don't need to be on the page so that you can defer it to after. What do you want?
Sure, book.
Book? They're all the same.
Cheers.
So one of the things with this technique, what happens if I put this thing in the iframe, but a browser has like maximum number of parallel requests it can make? Wouldn't that kind of compete with the things that are potentially informed?
Yeah, so the question is if the iframe is now going to create a new request, a new TCP connection from the browser, and that might compete with the other connections. So typically, the browsers do have a maximum number of parallel connections, which I believe is 16. Do you remember what it is? Does anyone know what it is? Or we can look at the browser's total. Usually, no, that's the maximum per domain, but there's also an overall maximum across all domains. We can look it up in the browser screen. Is it browsers.com or? Sorry. So yeah, that is a problem if you hit the maximum. Hopefully we load it fast enough. So we actually have numbers on how fast we load. Median load up time is 70 milliseconds from anywhere in the world. So we hope we don't hold up network connections for too long.
Correct, but the irony is the whole reason we did this was because this dude was slow, right? So we
Well, it's not because it's slow, it's because sometimes it might be down, and we don't want your site to dive and be down. So it's, connections, max connections, all right, so there's 9, 11, 35, 35, 16. So, I mean, there's like IE mobile is 16. So that's huge variance. And yeah, I'd probably be worried about these that have 9 because it's max per domain is 7. But again, try and load as fast as possible. It's in that off case where we're down, where it's going to be a problem.
So, but the iframe does compete with the.
It will compete, yeah.
Even though it is after the onload.
So again, different browsers have different priorities. They assign to different components. So typically JavaScript that's loaded inline has the highest priority. They try and load it as fast as possible. Images that are early on the page, I forget about the image priority. So CSS and JavaScript have the highest priority. JavaScript with defer has lower priority. So this browsers try to prioritize what it's going to download first versus second. And iframes I know don't have the highest priority. So if there are other objects that are competing, they will actually be put in queue before an iframe.
Correct. So I think maybe my confusion if it's a parent, let's say scripts have higher priority, but does a parent image have a higher priority than the iframe script, for example?
So that image will probably load beforehand. Again, I'd have to look into what. I mean, all these browsers have documented their priorities because they talk about it in conferences like last week. And I know Ilya spoke about them at
Yep, he talked about that.
but I don't remember what he said in terms of the full list. But another thing to consider is that this is not so this JavaScript is not inline. It's actually loaded using JavaScript, so it will actually have the lowest priority of all, since it's not seen by the look-ahead pass or anything.
Then in that case, we wouldn't need to put it up at the top, at the head end one?
We want to put we should not optimize for the worst case. We just need to make sure that we are not causing the worst case. But we want to be there for the best case that we will actually load up sooner.
Yeah, because I think this technique is very nice, and I'm thinking what we could use it on our site for. But then I think that within.
So typically, what I tell people is, if you're in control of all your JavaScript, then you can actually figure out what's the best way, and may not be this way. Loading it inline, in fact, might be the best way for you if you control your JavaScript. Or you may split it into two and say one of them is critical to the page, load it inline, and everything else is not, so I'll load it after all load asynchronous. And that might be all you need if you control all your JavaScript. But once you're dealing with JavaScript where you don't control the infrastructure, so you don't control the DNS or the servers it's running on, or in fact the provider, you want to take more precautions and make sure that that's not a single point of failure. Book a t-shirt.
Book.
So the t-shirt is just a medium size. It's I don't know if it's ladies medium or men's medium. I don't think Velocity has like different shapes.
So you mentioned that a few people were using this technique. Is this something they came up with independently? Because it seems like something that's quite specific.
Yeah, it's no, we collaborated on it quite a bit. So Stoyan and I collaborated with guys from Holak. We met over dinner one day, and we're doing the same thing. So let's exchange ideas and stuff. And
So yeah, I'm kind of curious, like how you actually came up with the idea, because it's interesting.
yeah. So I know the guys at Meetup were the first to come up with it, and it all comes up with realizing that iframes with no JavaScript source set the JavaScript force loads up immediately. And that's where sort of the spark came. Actually, the first attempt was with about blank, and we always kind of knew that about blank loads up is the best way to load up something without actually loading anything. Except somewhere down the line, which actually took something like 2 years to realize that it was causing security issues on IE6. Because IE6 has already got so many issues with SSL, nobody noticed this one.
How long did Facebook? You said Facebook was already.
Yeah, so
How long ago?
let's see, 2012. Oh, last year. So you get a choice between.
You see with the shirt, I already bought the book, so.
Are the ebooks as well?
There's paper copies of some ebooks that are released recently.
Alright.
But those are free. You can just grab them away.
Those are free. Everyone gets one.
You mentioned something about specific user agents doing bad things with cache.
Yeah.
Can you elaborate? Just the.
Let me see if I still have the open some. I don't actually actually have it open, but I have seen, I can't say it's specifically to a user agent itself, but user agents, when I say, it's a certain user's user agent.
Okay,
So it's the user's browser. And yeah, like I said, the clocks and all issues. I've seen problems running across browsers, so Chrome 23, Internet Explorer 8, 9.
So it's not a specific browser.
It's not specifically to a browser. Firefox 3.5.11, that's, if you ask me a specific browser, see, that's the worst when it comes to issues. The problem is that was just before they turned on automatic updates, so there's a ton of users still on that.
Yeah, we usually
Yes, so somebody had a question?
It could be the computer clock.
It could be the computer clock. So a lot of times browsers just use the computer clock. Yeah, it's interesting. We've seen times which are not even in this century. Like not even in the last century. Because we send the JavaScript timer back to the server on the weekend. And sometimes it's like 380,000, let's say, Unix timestamp, which is, it is in the century. It's just, yeah.
I also was curious about the same question that you asked, like how you work, how it came about and how you all work together. It reminds me of the way people might go about finding security exploits, right?
Yeah.
Thinking the opposite way, like I need to subvert the way it is done, but I need something else. And obviously this is different from the process. And you all were meeting and then...
No, we weren't always meeting, so I think it started off at conferences, so Velocity was 2011, where we started talking, Brian and I, and we met you guys from all that around the same time. So that's sort of when I think things started brewing. And I just pushed out the first version, which was fairly simple, which was just a dynamic script loader, but using an iframe instead. And then all the other problems started showing up. So like I said, we pushed it out of production. What else would go wrong? And then as soon as people would complain, we'd like, fix something and push it out again. Because we had this cache reloading thing we could do. We were just pushing out and flush everyone's cache immediately and see what happens. So we get a million beacons a day. Some of them will be right and some will be wrong. And it's, we'd like sit, so I would sit up at night, I'd generally push them out after midnight, looking at time zones when traffic would be lowest. And then just watch the logs to see which browsers are dropping in terms of beacons. So, alright, there's probably a bad internet browser. And then go ahead and look at that. So even after you test on your own, you get VMs open and stuff, so may not capture every possibility.
I think the process is almost as interesting as this, or is, it's how you go about making big changes when you have it live in a lot of places and you have to react. It's a really nice lesson for people.
Yeah.
Did you ever change the snippet that people put on the page?
So that was our main limiting factor. We could not change that. So until we sent out a mail and said, this is a better way to do it, so we'll go ahead and do that. Again, not everyone will do it, so our script actually needs to deal with both ways of doing it, factory ways of doing it.
There's one part I'm a bit confused. So you said that if we have the iframe and we do JavaScript calls, it loads immediately and the download fires.
Yeah.
And then later on I saw the document writes and says you subscribe to the onload event.
Yeah.
So that's the part that is confusing.
Yeah, that's a very confusing part. It took all of us a long time to understand exactly what was happening. And this is code that has evolved, so it's this is what you're talking about, right?
Yeah.
Yeah. So let's go. So when I do this, an iframe source, I'm only creating an iframe, getting a handle to the object. This is running within JavaScript. JavaScript is single-threaded, so this is going to run. Control is not going to go back to the browser until this is over. Now this code is in the same function. So this is going to then start executing. We're going to do this document and write. So even though the iframe has been created in memory and put into the DOM, at this point control hasn't gone back to the browser. So it's none of the events can fire, even though they might be in the queue. Right? So we've now attached an onload handler. We've done this, and now it exits from the function. At that point, control gets back to the browser, and the browser starts executing on these queued events. So that's the time when it actually sees that, hey, this iframe has an onload event that needs to fire. And so it fires that, which then calls this, and then runs this.
Wow.
Did you get a book? Yeah. Yeah, it took a while of just staring, what the heck is happening here? Why is it working?
And this is also part of the snippet that the people put on their, in their HTML.
Yeah. So it's, just don't put it back on this. Maybe I'll be able to see. So this is my website, you can go on news source anytime. This is the function. Oh, actually, this is the old version. I haven't updated my site. This doesn't have the documented domain stuff because I don't actually set documented domain on my site. So, but yeah, essentially you can actually see what it was before. So previously we were writing all the JavaScript to a string and then writing that string into the document using document.write, which we tell everyone what to do. Should I close this? You recording it?
Yeah.
All right, one book to give away. Who asked that? Who wants the book?
That's a pretty good book, guys.
Well, I'll take the book back. There's a question.
Who asked the question this time?
Oh, I
Do you have a question?
Well, yeah, not now. It's not a question, it's just an observation.
Right.
You seem just so cheerful about about the fact that people are not following the rules out there. Proxies are not obeying cache expires. Browsers are messing up with caching. And my tendency would be to say, what's up?
Well, you know, if none of this happened, then I could just be automating my job. But it's, I don't know, it's obviously not what I want to be doing all the time. I like to be actually doing the measurement and figuring out how to make things faster. But eventually all of these, knowing how these bugs, or what these bugs are, is one way of actually understanding how to make things faster. So it eventually comes down to, all right, these users exist, what can we do to make their experience better? And so getting all of those metrics on what kind of users exist is sort of fun. And we get pretty jealous. You have to plot on a log scale because all of those things down there are visible in place.
This is off topic to this talk, but it's something that I was doing today. And I don't know, I was just noticing you were talking about it. I mean, what's your favorite way of testing like the wide array of browser types there are out there?
Yeah. So, like I said earlier, when we generate a new version, we'll test it for a day or so just using VMs. So I've got 10 different.
Okay, so you just like going to different.
Yeah, but again, that doesn't test everything. I've got one Android device, one iOS device, and a bunch of Internet Windows VMs that I'll test on, but that still won't cover everything. I mean, I don't have Firefox 3.5, and I don't have every version of the iOS browser out there. So eventually we'll just push it out and just say, all right, we've covered the majority of them, let's see where the minorities are. So,
if you don't know about modern.ie, it's a new site.
Yeah.
It's super useful.
Yeah, I saw that.
Modern.ie is pretty good.
You can pull it up, but it's called modern.ie. Microsoft released this recently, and they have prepackaged VMs for older versions of IE.
It's because people are yelling at them for getting rid of the compatibility mode. Well,
Yeah.
or maybe not because, but
Yeah, modern.ie, pretty good website. This is where you get your VMs to test on different versions of Internet Explorer.
And it's great, because Microsoft publishes it, so there's no like licensing issues, you don't have to register the copy of like a Windows. They work very well.
So interesting note about Internet Explorer is every version of IE contains the full binary of the previous versions, which is why they can switch modes.
But they stopped at an 11, right?
I don't know.
Yes, they did. They said that putting in compatibility mode was not the same as actually testing on the old browser, because they didn't want to continue perpetrating that false belief.
So that had some very interesting side effects because we started seeing like IE7 with navigation timing, which was throwing us up completely. We were on these beacons after again. You guys know.
Yeah, we were seeing more traffic from IE7 than from IE9, I think, and it was just compatibility mode.
This is precisely IE8.
This is for all. This has like 6, 7, 8, 9, 10, 11. You can get.
Whatever is provided is like IE8 precisely.
Yeah, so you can look at the. If you go like get tools, you can see the VMs they provide. They have it's like cross-platform. It's VirtualBox. Yeah, you can see them there.
There's even like a GitHub project called like
IEVMs.
IEVMs, yeah.
Yeah, so that's basically obsoleted by this.
Shell script, and it'll download all the VMs. So you need like 100 gigs of space.
80 space.
Yeah.
Right. So I lost track of who asked a good question for what. I think we'll through. Right.
You went first. I really was just wondering.
Because that came out.
I really was probably
She's going to borrow this one.
There'll be more bugs in future meetups.
All right.
Thank you.
So one other brief announcement, if you want to discount to Velocity London, there's some cards there with the coupon code on them. And social pizza tonight, so let's thank them real quick again for the pizza.